is limits in plain English.
Je ne comprends pas.
No, sir.
What?
Well, let's show you what a limit looks like and how easy it is to graph it on a graphing calculator.
We will teach you what a limit is and how to solve it using substitution, rationalizing, and dividing out. Now we'll show you the different methods in finding a limit.
Also, we'll show you the different types of limits, their properties, and how trigonometry comes into play with limits.
I'll show you what limits do not exist and when they are infinite.
The limit does not exist.
Hey, do you know what a limit is?
No, but it sounds like what a number can't be.
You're wrong. This is what a limit is.
Well, a limit is a number that f of x gets closer to as f approaches c from either side.
In other words, it's a value of y as x approaches a constant in any function.
Here, we're going to find the limit of the function x cubed minus 1 over x minus 1. On a graphing calculator, you can usually use your trace method, or you can use a table to find a limit. Here in GeoGebra, we can pick a point, place it anywhere on the graph, and use our cursor to drag the point. Pay attention to the point A, x and y coordinates. As we drag point A along the graph, from the right, as x approaches 1, y approaches 3. And again from the left, as x approaches 1, y approaches 3, until A is undefined. You can check this by plugging in 1 into the graph. And as you can see, the graph is undefined at 3.
First, there is direct substitution. We use this when the limit is found by plugging in c. So let me try this problem. Here we have the function 4x squared plus 3 with the limit approaches 2. What you would do is just plug in the 2. It's very simple. So 4, 2 squared plus 3. 2 squared is 4 times 4 plus 3. 16 plus 3 equals 19. So the limit is 19.
Now let's try the dividing out technique. Use this method when substitution doesn't work. Let's look at this problem. The limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. Direct substitution won't work here because here we end up with a 0 in the denominator. To get rid of this denominator, we're going to factor out. After canceling out the denominator, we end up with x minus 2. This comes in handy because when the function agrees at all but one point, making their limits equal. Therefore, the limit as x approaches negative 3 of this function, both of which equal negative 5.
Now we'll look at the rationalizing technique, which is used to find the problem here. The limit of x as x approaches 0 of the square root of x plus 1 minus 1 over x. We must rationalize the numerator by multiplying the equation by the conjugate. After canceling out the x's, we are left with 1 over square root of x plus 1 in the denominator. Now we can use substitution. And the limit is 1/2. Now we're going to discuss the different types of limits. In previous problems, we were discussing the general limits, but did you know that there are left-handed and right-handed limits? In this graph, you could see that the limit is approaching 1 from either side, but do not meet up, so it's a step function. When it approaches from the left, this is how the notation is written. It's going to be as the limit of x approaches 1 from the left, and you put a little minus sign, and you just take the limit of the left-hand side. And as it approaches from the right, it'll look like as x approaches 1 from the right, and you add a plus sign. The limit does not exist!
There are 3 ways a limit can fail to exist.
In the step function, the left and right hand limits are not equal. In this trig graph, the function oscillates between 2 fixed points as x approaches c. In this asymptotic graph, the function approaches positive infinity from both sides.
So here's a recap.
There are 3 different ways of finding a limit.
such as dividing out, substitution, and rationalizing.
You also learned about left-handed and right-handed limits.
And you learn when a limit does not exist.
Goodbye!